Okay, Edx M3 Vertical Circles question, January 2011, question 7. So as usual, take a moment to pause the video and have a good read of the question. Notice in particular that this is a particle attached to one end of a light rod rather than a string. So this is an example of one of those questions where the object, the particle, is constrained to move in a circle. So long as that rod is moving, it has to move in a circle. And that's important in the second part of this question. So let's do first part first of all. We've got to show this expression that links the velocities at those 2 points A and P. And it's an energy problem. There's conservation of mechanical energy because the tension in the rod does no work, because it's at right angles to the direction of motion at all times. So we've got kinetic energy plus gravitational potential energy is constant. And I've worked out the height difference between A and P, and I've worked it out here. So that will give me the difference in potential energy, gravitational potential between A and P. So it's a fairly straightforward bit this. The kinetic energy at A is a half mu squared. The gravitational potential energy at A compared to P is mg L cos alpha minus cos theta, and that's equal to the kinetic energy at P, half mv squared. And if you look carefully at that, if you divide by m throughout, double everything, you get the expression that they've got. B squared equals u squared plus 2gl cos alpha minus cos theta. Now remember, that will give us the velocity anywhere, so long as we put in the required value of theta. Next bit then. Right, for the next bit, it tells you cos alpha is 3/5 and P moves in a complete circle. So it keeps moving right the way around. We know it's attached to a rod. So what this is really saying is that V is greater than 0 at the top. So at the top, V squared is u squared plus 2gl, we know cos alpha, they've just told us it, 3/5 minus cos of 0 is 1. So we get u squared minus 4/5 gl. And we know it's still moving at the top, so this quantity is positive. So u squared is greater than 4/5 gl, which I think is what they want. That's right, take the square root. U is greater than 2 square root gl over 5. That's that bit done. One more bit to do, and more marks for this next bit. Right, and I've written this out because I keep making mistakes when I'm trying to speak and write this out. It looks worse than it is. It's fairly straightforward, but there's just fiddly terms to put in. So let's talk through it. What the question tells you is that least tension is T, the greatest tension is 5T. Now, putting that another way, since we know the least tension is at the top, and the greatest tension is always at the bottom of a circle, what it's saying is the tension at the bottom is 5 times the tension at the top. So we need to work out expressions for the tension at the top and the tension at the bottom using Newton's law towards the center, and that's what I'm doing here and here. So you might like to pause the video and just check those two equations. That's the force towards the center is equal to mv squared over r at the top and the bottom. And when you're ready to carry on, over on this right hand side, I've used the v squared equation to work out v squared at the top and the bottom. Theta equals 0 at the top and 180 at the bottom. And then down here, all I've done is worked out an expression for the tension at the bottom and put it equal to 5 times the tension at the top. If you look carefully, you can see how I put that and that and that and that together to get this one. And although it looks a bit messy, you can multiply through by L, divide right through by M, collect up the U squared terms. It's fairly okay, and you get the expression they want in a couple of steps. And that's the end of it. So looking at the marks, for the first part of the question, basically for this there was an M1A1 for working out correctly the height difference, and then there was another couple of accuracy marks, one for the correct statement about conservation of energy, and one for getting the correct final expression. So 4 marks for that part. For the next bit, there was, I think, just another 4 marks. So M1, again, it was M1, A1, M1, A1. So 2 method marks, 2 accuracy marks. The method mark of using the v-squared equation to get the velocity at the top, and accuracy for getting that correct, and then a method mark for saying the velocity is greater than 0, and a final accuracy mark. And for the last part, the 9 mark one, now for this, there was basically method and accuracy marks, M1A1 for resolving, and then method and accuracy marks for the let's just see, there's a total of 9, 1, 2, 3, 4. It's basically M1A1, M1A1, A1. Those M1A1's method and accuracy marks are not just for putting in here, not just for putting theta in and finding V, but for that substituting the V squared in to the tension expressions and getting this. So those method marks were the whole of this bit. And that's it. So I hope that helps. That's the end of that question. I'll leave you with some information on the Further Maths support program. Thank you.